Lesson 11, Solution Sets for Equations and Inequalities. The instructional outcome: understand that a solution set is a set of values that one can assign to the variables of the equation that makes the equation a true statement. So in this particular lesson, we pick up where we left off in lesson 10, where we give this particular equation that we want students to consider, this 7 plus p equals 12. And so we allow different p values to be defined as different values. So here, for example, we let p equal 0. And then we ask the student, say, well, does 7 plus 0 equal 12? And the student will say, false. That's not true. And so then we ask the students, well, what if p equals 4? Would 4 plus 7 equal 12? And then the students would say false. So then we bring up one a little bit more complicated. What about 7 plus the 1 plus square root to 2? So the students will think about it for a moment and come up with the conclusion that, again, this is false. So then we bring up two more. The p equals, what about 1 over pi compared to p equals 5? And as the students think about it, there's only one that's going to end up being true, and that is the 7 plus the 5 is going to equal 12 in this particular piece. So the truth value for all of the other four are false, while only one of them is true. In the student's Eureka manual, they provide this illustration where they want them to think about, and we observe this idea of a gate right here, like a movie gate where movie stars or something wants to go through, and for some reason the 4 made it through, when all these other values, the 5, the 6, the 0, the 10, and others, have not made it. And so we see this idea that some numbers have to go this way, while some numbers get access here. And while it's a little bit difficult to read some of these, what allows them to go into the gate is this notion of x squared equals 3x plus 4. While here, if x squared does not equal 3x plus 4, they would go to the rejects. So the teacher would ask, well, why did the 4 make it past the gate? And what we want the students to be able to reason and discuss with the teacher is that if I had 4 squared and I set that equal to 3 times 4 and I add the 4, well, 4 squared is 16. 3 times 4 is 12, and if I add 4, I get 16. It's true. And so the 4 was able to have the gate open and go through, and is a part of the solution set. Why did these other numbers not go through or not make it through the gate is because if I squared them and solved them, that would not work out to where it would be a true statement. So the major thing that we want to drive home with this piece is this notion of a squared equals 25. Each student is going to get tested on their ability to rhyme or reason this piece. And so we want to know that their ability to handle x squared is okay. So if we look at it, one can describe a solution set in any of the following ways. In words, we could say a squared equals 25 has the solutions 5 and negative 5. Or in other words, what the teacher tells the students, if I have a squared equals 25 and I want to solve for a, then what I'm going to do is I'm going to take the square root of both sides. And so when I write my answer down, I will say a is equal to, and the square root of 25 is 5, and then the teacher will tell the students to put a plus or minus. And that is mainly because if we think back to our products, 5 times 5, well, that's equal to 25, but also negative 5 times negative 5 is also equal to 25. And we want the students to note that this comes in a pair or a solution. you don't want to be surprised if your teacher decides to evaluate that. In set notation, the solution set of a squared equals 25 is negative 5, comma 5, or in other words, the two values that did equal or make it a solution set or true statement. In a graphical representation on a number line, the solution set, we would have the students draw a number line and they would put a dot here at negative 5 and a dot here at 5. And so in homework, the students will be given an opportunity to give in different sets like this. They'll ask for a description in words, they'll ask for a description in set notation, and they'll ask for a graphical representation to represent that information. So, for example, if we look at this one right here from earlier, they picked a solution set of 7 plus p equals 12. Well, we noted in our earlier example that if we let p equal 5, then that would make it a true particular statement. And so then we would ask the students to say, what is it in words? And so the students would say the solution set is p equals 5. In set notation, we would have only the 5, as opposed to last time we include the negative 5. And on the number line, we would have them draw and place a dot at the given 5 value that made it true. One more example to consider is, what if we ended up with a set that gave us an inequality to where they want us to solve for w, where w plus 2 is greater than 4. And so we want the students again to be able to write the solution set in words, in set notation, and give us a number line as a graphical representation. So if I solved it, my statement would be is w must be greater than 2. How did we get the greater than 2? Well, if I take my w plus my 2 and I say greater than 4, if I subtract 2 on both sides, then I get w is greater than 2, or 4 minus 2 equals 2. And so w must be greater than 2. In set notation, it will be w within the domain of all real numbers, where w must be greater than 2. And if we graph that on a number line, we would have our number line here. We would put an open circle on 2, open circle. So as a footnote, if we had greater than or less than, that is synonymous with an open circle. Or if we have greater than or less or equal to, or less than or equal to, then that is synonymous with what is called a closed circle. So since here we have greater than, it's an open circle, and then we are going to shade everything to the right of 2. We'll put an arrow to indicate that it does continue past 8. So for our lesson summary, we just want to recap that a solution set is an equation written with only one variable symbol is the set of all values one can assign to that variable that makes that equation a true statement. If we look a little further down in words, if we're focusing again on that a squared equals 25, we mentioned that it has two solutions, the positive 5 and the negative 5. One other indicator that there are two solutions here is the fact that this is a squared, so we will be looking for two solutions. And so we look and see how it's written in set notation, and then the fact that we plotted a point here at negative 5 and a point at positive 5 to represent this notation. And so do keep that in reference. When assessed in class, we will be looking for words, set notation, and graphical notation, and I would pay very close attention to this notation of how it has two solutions, because it will more than likely be applied to the testing environment.